Today, we are going to discuss deployment strategies. Specifically, we are going to speak about progressive delivery because that is really the most likely strategy you are going to use. And trust me, there are many types of progressive delivery. And we are going to see how all that works, how it doesn't, what it's for, and what's not. And I will use my artistic abilities, which are very low, to draw how it really works, what is Big Bang or recreate strategy, what is blue-green, what are rolling updates or ramped strategy, Canary deployments, and so on and so forth. So today's subject is progressive delivery. And I will not go into details what is progressive delivery, but more into what are different practices or ways to do progressive delivery. I will only say that progressive delivery is a deployment practice that aims at rolling out new features gradually. And it can be many different things. And we are going to see the major ones in a moment or two. So my name is Victor and this is DevOps Toolkit series channel. Please subscribe. Please subscribe to get notifications when I publish new videos. Buy one of the books or the courses in Udemy if you want to support this channel. What else? Yes, listen to the DevOps Paradox podcast because that's where me and Darin explore cool things and interview cool people, and that's about it. Let's jump into deployment strategies right away and try to explain everything in 20 minutes or less. So, no matter which strategy we choose, there are two constant things we absolutely always need, and that is a cluster. And let's see, so this is a cluster, and we need a load balancer, usually external to the cluster, so LB. Now, from there on, things tend to differ greatly depending on how we deploy stuff. So before we move into progressive delivery, let's see what were we doing before using any of the progressive delivery techniques. And I will call that Big Bang deployments. I like the term. I'm not sure whether anybody else is using it because with Big Bang deployments, we have a release, then we destroy that release, we shut it down and put a new release in its place. So usually Big Bang releases are associated with single replica applications. That does not mean that only those who are running single replica are using it, but let's say that if you don't have multiple replicas, you cannot do anything else. So any other type of deployments is out of the scope. So long time ago, when I was very young, the way how we were deploying is that we would have, let me change this, we would have a release. This is an application and it would be version 1, let's say, of the release. And then when we decide to deploy a new release, we would shut it down, put a new release in its place. The problem with this, and of course load balancer would be pointing always to whatever is the currently running release. The problem with that is that between shutting it down and actually after shutting it down and until before the new release is up and running, there is some downtime. It could be 1 millisecond, it could be 1 second. Yeah, I've been in situations when actually the release process takes a few days. So it's a risky thing that produces downtime, and that's not what we want. So over time, we all moved to one form or another of progressive delivery. And the first one that became greatly popular is blue-green deployments. What do we do with blue-greens? Here we go. Let me change the color, make it nicer for you. So with blue-green deployments, we would have an application, and it could be multiple replicas. So let's say that this is application, this is second replica of the application, third replica, and fourth, right? And there would be all releases 1, v1, release 1, or version 1 and version 1. And the load balancer would be doing round robin to all those replicas. It could be one replica, it doesn't have to be 4 as in this example, any number of replicas. And we would call this, let's say, green release. I cannot use green color because I'm behind the green screen. Tricky. And then when we want a new release, we would spin up the same number of replicas of a new release, like v2, 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 and the last one. Now what is happening, and we would call this, if blue-green, if this one was called green, then this one would be blue. Now, at this moment, all those replicas are running, but our users keep seeing the old release, keep seeing this one, because we didn't change the load balancer. And then, at one moment, we would instruct load balancer to do two things. First, to start sending requests to the new release. Then, to stop sending requests to the old release, but, and this is important part, to still be configured to receive responses from that release, from the old release, because we want users who were in the middle of using the old release to finish doing whatever they're doing. Eventually, once the responses stop coming, it would completely remove the load balancer configuration going to the old release. And in that way, there was no moment in time when one or the other release was not running. So there shouldn't be any downtime. And then when we want yet another release, let's say 3, then we would, keep, and this is now important, we would keep this old release running. And why we want to do that? Because in case we want to roll back, we can just reconfigure again load balancer to start sending requests to the old release and stop sending them to the new one. And then if we would like to deploy a third release, we would replace the old one, the one that where requests are not going anymore, with release 3, 3, 3. And so on and so forth. So at every given moment, there would be something running in a cluster. We could easily roll back to the previous release just by reconfiguring the load balancer. And we would live happily ever after. Now, the problem today with blue-green, actually there are quite a lot of problems. One is that you need to double your infrastructure. So if you need, I don't know, like 50 gigs of RAM, or if you need 5 servers to run one release, you would need 10 servers to run it as blue-green, because 2 copies of your application are running at any given moment. 2 releases are running at any given moment. And that made sense in the past when spinning up new releases, making new deployments, initiating applications, and so on and so forth was slow. That's reason number 1. Second, because it was unreliable, and it was unreliable because it was mutable. So rolling back by spinning up what was there before was a complicated task. But today, that's not true anymore, because we have containers. Containers give us immutability, and we have containers, Kubernetes, which allows us to spin up whatever we want, whenever we want, like this. So it doesn't make much sense today to use blue-green deployments. We can think of it as pioneer of progressive delivery that made a lot of sense in the past, but not today. And that leaves me to another one, which is rolling updates. Now, what we do with rolling updates, it starts the same as blue-green. Let's say that we have 4 replicas of release 1 or version 1 of our application. Now, when we want to end load balancer is always going to all the replicas, right? Now, if we want to deploy a new release, what we would do is we would roll it out iteratively, right? And that would mean that we would deploy one replica of the new release, of the new version of the application. And once it's healthy, load balancer would start forwarding requests there as well. And then we would shut down one replica of the old release and then repeat the process. Hey, second replica of the new release, shut down the old replica, stop sending traffic, of course, first, and then yet another replica, load balancer goes there, shut down load balancer, sending request to one of the old replicas, shut down the replica, and then whatever we need, right? And load balancer and shut it down. And this is much more efficient because for two reasons. First, because we don't need to multiply, to double our infrastructure to run both releases in parallel. Second, we can somehow, not really in a good way, but somehow we can rely on health checks and say, because if there is something wrong on a health check level with this new release, it would never progress until one replica of the new release is not healthy, or 10% or whatever the criteria is, it would not continue progressing. And that happens to be the default deployment mechanism in Kubernetes. So if you're using, let's say, Kubernetes deployments, and if you did not change the deployment strategy, you are using rolling updates. Now, over time, this is great because it's simple, right? And it is default strategy in Kubernetes and many other places. And by the way, what I'm saying now about applications equally applies to the cluster. If you replace those boxes in your head with virtual machines, you would get exactly the same result. Most of Kubernetes clusters, for example, themselves are upgraded using rolling updates. If you go to Google Cloud or Azure AKS or EKS, you would see that actually upgrade process creates a new node based on the new version of Kubernetes, shuts down the old one. In between those two actions, everything is moved from one to another, and then it repeats the process of spinning up a new node, shutting down the old one, and so on and so forth until your whole cluster is upgraded. So the same process applies to applications as to infrastructure, even though I am using applications as an example. Then we have Canary deployments. Now, Canary deployments are a bit more elaborated than rolling updates, even though they are in principle very similar. So again, if we have one release running, I will continue using 4 replicas for no good reason. We would, and load balancer is sending requests there. We would spin up a new release. And normally, in this case, a new release would be related with horizontal pod autoscaler in case of, this is actually number 2 over here. So the new release would be associated usually with autoscaler of some sorts. And so there might be one or more replicas running, or the system would make sure how many replicas are running. That really differs from one case to another. But what really matters is that we would have some form of metrics storage. So these are metrics. It could be, for example, Prometheus or Datadog or what's not. And then we would have some type of agent controlling how Canary deployments work. So what it would do is that spin up this new replica or more replicas, depending on situation. it would instruct load balancer to start sending requests there, but it would also configure it to send a certain percentage. So it would say, let's say, start with 10% going here and 90% going here to the old release. So we would have certain percentage going to the new release and everything else going to the old release. And then the agent, and during all that time, of course, metrics are being sent to some storage like Prometheus. And agent would consult metrics and say, hey, what is the error rate? What is the response time? And so on and so forth. We would instruct the agent how to validate whether the new release is okay or no. And actually we can think of those metrics as testing in production, right? Imagine that we are testing in production, but a new release of application available only to a fraction of users. And then if everything goes right, it would change the percentages and say now 20% goes to the new release and 80% goes to the old one. Continue checking metrics, execute queries, validate, run some sort of test. It's not really tests, but metrics observability in production is really equivalent to test. And if everything goes fine, it would continue the process, increase to 30% or 50% or 60%, 70, 80% of the traffic going to the new release. And at the same time, it would be shutting down old release because the traffic is dropping and there is less and less needs to have many replicas of the old release, and in parallel it would be increasing the number of replicas of the new. And there could be two possible outcomes. Everything is fine, continues being valid release. Our users continue having good experience with it, and then the process continues until it reaches 100%. Or there is something wrong detected by querying metrics, and when that happens, if that happens, and if it repeats over time, we would say, hey, no, this is a bad release, 0% goes here, shut it down, continue or restore the previous state and start redirecting 100% to the old release. And that's where we are today. Canary deployments, and there are many variations of it, are probably the best way you can deploy applications today. But not every application can be deployed for that, or not every team can use it, because you need to have advanced observability, you need to be secure in your metrics, you need to be secure in your knowledge how to validate whether a release is working well or not. You need to be able to have application that is horizontally scalable, and so on and so forth. There you go. Those are the most commonly used deployment strategies. Which one should you use depends on many factors, on the architecture of your application, on your maturity, on your reliance on automation or lack of automation, how much you trust your metrics, how much you trust your processes, and so on and so forth. Now, of course, if we look at only those four, the objective should be to go for Canary deployments. You might not be ready for it, and then rolling updates are probably the second best option. If you're running Kubernetes, though. If you are in before Kubernetes era, then blue-green deployments are probably a better choice. If you use Kubernetes, just discard it. It's the worst option of all. And if you have an old application that cannot scale horizontally, that cannot have, and this is now the most important part actually, if you want to do anything but Big Bang, your releases need to be backwards compatible, because the only way to avoid downtime is to have at least 2 replicas running in parallel. And if one of them is the old release and the other one is the new release, and there is no guarantee which one will be used by your users, then every new release needs to be backwards compatible. Thank you much. Thank you very much for watching. This is me, Victor. Please, please, please hit the like button if you liked it. Subscribe, and if you would like to sponsor this channel, if you would like to help keep it going, then you should buy one of the books or the courses on Udemy. What can I say? I brought them, and it buys coffee and pizza and Red Bull and whatever else is needed for working late nights after office hours to create material like this. Thank you so much for watching. See you next time.